Agent number 4, the Knowledge Retrieval Agent, solved a critical problem in the AI stack. It grounded language models by locating the exact file needed to answer a user's query. But finding the file is only half the battle. This chart shows where Agent number 5, the Document Intelligence Agent, takes over. It sits directly in the middle of the knowledge and retrieval tier, immediately following the retrieval step. As detailed in Imran Ahmad's textbook, 30 Agents Every AI Engineer Must Build, this agent is the specialist designed to process what happens next. In a live production environment, enterprise data rarely arrives as cleanly formatted text. It is trapped inside noisy, scanned PDFs, 50-page legal contracts, and crumpled paper receipts. A retrieval agent's job ends at the document's edge. If the system cannot penetrate that visual chaos to extract clean, trustworthy data, the retrieval itself provides zero operational value. There is a common assumption among developers that you can simply drag a complex invoice into a multimodal language model and ask it for the total. Feeding a tabular document into a linear language model destroys the grid's spatial relationships, reducing it to chaotic word soup. When the visual structure unwinds, a label like total due easily disconnects from its actual value, snapping instead to a nearby number like $11,000. Enterprise billing and almost right extraction is a catastrophic financial failure. A document is not a string of text. It is a picture with coordinates. The only way to reliably parse it is to treat spatial position as meaning. This diagram outlines the 6-stage document intelligence pipeline. In Stage 1, ingest and triage, the agent detects the incoming file type, routing clean digital feeds to extraction and scanned images to processing. Stage 2 is pre-process and OCR. The engine converts pixels into characters, assigning a mathematical confidence score to every token. In Stage 3, layout parse, it maps the page's geography and reading order. Next is schema extract. The agent pulls required values, attaching their exact physical bounding box coordinates. Finally, high-confidence data routes automatically to the target database, while low-confidence data triggers human review to retrain the model. We have replaced a black box guessing mechanism with a deterministic, auditable machine. It extracts what it knows, and it explicitly flags what it doesn't. To prove this architecture works, we have to look at the Python implementation from Chapter 6. This code block defines the pre-process and OCR function. Notice the confidence threshold equals 60 logic line. If a token's confidence falls below 60, it is flagged, preventing bad data from poisoning downstream logic. This section introduces the token data class, forcing every recognized word to carry exact x, y, width, and height coordinates. Down in the join line logic, the script uses those precise coordinates to mathematically rebuild horizontal lines. By storing spatial coordinates alongside the text, the agent generates an auditable receipt for every single extracted fact. This block details extraction logic. Instead of reading linearly, the agent hunts the coordinate space for key keywords like total due. Because OCR is rarely perfect, it executes a fuzzy matching pass, allowing for slight imperfections. Once located, the agent executes pass 1, looking for the numeric value immediately to the right of the keyword. If empty, pass 2 drops down to the next physical line, staying within the exact same vertical coordinate band. These strict spatial rules guarantee the agent extracts the correct number. The word soup threat is completely neutralized. In an enterprise accounts payable department, this system might process 10,000 uniquely formatted vendor invoices every month. The agent auto-posts the 95. This agent has strict operational limits. If your pipeline already receives well-formed XML or clean database exports, running this system adds unnecessary latency. And while it excels at structuring single files, it lacks the cognitive ability to synthesize arguments or spot overarching trends across 100 different documents. That boundary is why this agent serves as the middle runner in the Chapter 6 information relay. Agent number 4 finds the raw document in the archive. Agent number 5 penetrates its visual layout, structuring it into clean, proven JSON data. With that clean data secured, the baton passes to agent number 6, the scientific research agent. That is the intelligence capable of taking thousands of structured data points, uncovering hidden patterns, and formulating hypotheses at scale.